The darkness between stars is not empty. It is a vast, silent ocean through which things occasionally drift, travellers on million-year journeys that began around alien suns. When one of these travellers enters our solar system, it should be a moment of pure random chance, a cosmic surprise. 3i Atlas should have been exactly that. Announced to the world in late October 2025 as only the third confirmed interstellar visitor, it was presented as a newly discovered comet, an exciting scientific target to be studied in its fleeting passage. But that story, the official one, is wrong. It is a carefully constructed facade. The truth is far more profound and unsettling. 3i Atlas was not discovered, it was intercepted, and the evidence for this audacious claim didn't come from a press conference or a scientific paper. It arrived quietly and damningly in the digital shadows of the internet on November 2nd, 2025, a leak so catastrophic to the official narrative that it forces us to reconsider not just this object, but our entire understanding of who is watching the skies and what they've been waiting for. This is the story of a secret 2 decades in the making, of a surveillance network hidden in plain sight at the edge of Earth's dominion, and of a single, inescapable question that hangs over every grainy, classified image. If 3i Atlas was a surprise find in 2025, why was a multi-billion-dollar military-grade deep space tracking system, one that would take generations to build, already fully operational, perfectly positioned and intently focused on its approach? The answer to that question pulls back the curtain on a realm of prophetic academic research, black-budget projects, and a timeline of preparation that suggests foreknowledge of an event that, by all rights, should have been impossible to predict. Before we dissect the leak that rewrites history, I want to know who's out there, right now, stepping into this mystery with me. This isn't just a story you watch, it's a puzzle we're assembling together. If you're as captivated by this enigma as I am, go ahead and like this video and subscribe to this channel. The implications of what we're uncovering are unfolding daily, and you will not want to miss a single development. Make your voice part of this investigation. Leave a comment down below, tell me your location, what time it is for you right now, and most importantly, whether you believe the public is being told the complete story about 3i Atlas. Now let's begin at the moment the timeline shattered, November 2nd, 2025. The venue was a private online forum, a digital watering hole for a specific breed of enthusiast. Amateur astronomers with backyard telescopes powerful enough to track classified satellite maneuvers, retired aerospace engineers with lingering contacts, and satellite trackers who treated the orbital paths of secret government assets as a nightly puzzle. These were people who understood the subtle language of orbital mechanics and the telltale signatures of military hardware. Into this realm of informed speculation, a user with a cryptic handle and no history posted a single unassuming link. The file it led to was a data packet, compressed and encrypted, but not so securely that the community's savvy couldn't crack it open within the hour. What spilled out was not the usual grainy, long-exposure astrophotography. It was a trove of professional, clean, and terrifyingly detailed surveillance data. The subject was unequivocally the interstellar comet 3i Atlas, captured in the days following its perihelion, its closest, fiery dance with the sun, but the provenance was impossible. The metadata woven into the very fabric of the image files carried a distinct digital signature, a combination of alphanumeric prefixes, checksum formatting, and directory structures that veterans of previous defense sector leaks recognized instantly. This wasn't NASA, this wasn't the ESA. This had the fingerprints of the United States Department of Defense's most classified satellite architecture all over it. The leaked packet was methodical, containing 3 distinct and complementary datasets, each more revealing than the last. The first was a series of high-resolution images labelled Oracle G. The clarity was breathtaking, inhuman. They showed 3i Atlas not as a fuzzy smudge of light, but as a defined, structured body. Surface features, what appeared to be surface features, were discernible. The nucleus was sharp, set against a glowing coma, but the vantage point was the true revelation. The metadata tags placed the imaging platform at EML1, Earth-Moon Lagrange-point 1, a gravitationally balanced parking spot in space about 60,000 kilometers from Earth, perfectly situated on the line between our planet and the Sun. No public scientific instrument of such capability existed at EML1. The solar observatories there, like Soho or Duskovo, were not built for this kind of precision tracking of deep space objects. Oracle G implied a dedicated surveillance platform, a silent sentinel with a crystal clear view of the approaching comet. The second dataset was labelled Argus Vis. If Oracle provided the stunning portrait, Argus provided the forensic autopsy. These were multi-spectrum captures, imagery stacked across dozens of narrow wavelength bands simultaneously. The data revealed the comet in the infrared, showing heat signatures, in the ultraviolet revealing energetic processes, and in specific emission lines for molecules like cyanogen and diatomic carbon. This was hyperspectral imaging on a scale that dwarfed any known public space telescope. It was the kind of capability you would design not just to see an object, but to understand its exact chemical composition, its temperature, its activity from a staggering distance. It was, for all intents and purposes, a remote laboratory. The third and final component was the most chilling in its clinical precision: trajectory overlays from a system simply called Cassandra. These were not the approximate, gradually refining orbital plots released by the minor planet center. These were razor-sharp predictive vectors, with confidence intervals measured in mere meters per second. They showed the comet's past path and projected its future, one with the kind of accuracy reserved for tracking ballistic missiles or guiding interceptors. The data streams showed continuous tracking, not sporadic observations. It was a record not of discovery, but of constant, vigilant monitoring. But it was one specific image from the Oracle G set that froze the blood of every analyst who saw it. A high-contrast black and white frame that stripped away colour to reveal pure structure. At its centre was the nucleus of 3I Atlas. Emanating from it were 4 brilliant lance-like jets of plasma. They were not chaotic, not the wispy, irregular tendrils of a typical comet's outgassing. They were stark, geometric, and arranged with near-perfect symmetry, extending out along what appeared to be the cardinal directions. They glowed with a bright, almost electric green hue against the absolute black of space. The symmetry was shocking. In nature, especially in the turbulent, heating-induced violence of a comet's coma, such perfect order does not emerge. Chaos reigns. This image suggested control. It suggested a phenomenon that was either so bizarrely natural it defied all previous models, or something else entirely. The immediate visceral reaction across the forum was a unanimous, silent understanding. Comets don't do that. The timing of the leak was not random. It was strategic. It landed just days after the public scientific community had itself been stirred into a quiet frenzy. Observations from the Hubble Space Telescope and a network of European ground-based telescopes had confirmed something odd. 3I Atlas was not brightening in a smooth curve as it receded from the Sun, as physics dictated. Instead, its luminosity was spiking in sudden, discrete jumps. Brief, powerful flares of light that had no correlation with solar heating or rotational phase. Astronomers were puzzled, publishing preliminary notes calling the behaviour anomalous and requiring further study. The stage was therefore set. The scientific world was already aware that this was no ordinary comet. Then, the leak delivered not just confirmation of the anomaly, but a monstrous context for it. A secret eyes-only surveillance apparatus had captured it all in far greater detail, long before the public telescopes had even begun to look. This is the genesis of the paradox, the crack in reality that this story forces open. The official timeline is clear and simple. 3I Atlas was discovered by a public survey telescope in late October 2025. Its existence was announced, and the global astronomy community turned its instruments to observe. Yet, the infrastructure detailed in the leaked files, the Oracle platform with its crystal-clear L1 vantage point, the Argus Vis system with its godlike multispectrum vision, the Cassandra database with its missile tracker precision, represents a system of such staggering complexity, expense, and technological maturity that it cannot be conjured into existence in weeks. You do not build such a thing on a whim. You do not even build it in a few years. Its existence implies decades of quiet, determined development, a long-term project with a singular, focused goal. This creates an irresolvable conflict that observers have termed the timing paradox. If 3I Atlas was an unexpected guest in 2025, why was the most sophisticated welcome party in human history already deployed, rehearsed, and recording its every move? The only logical conclusion is that it wasn't unexpected at all. The surveillance network wasn't built to find it after the fact. It was built because someone knew it, or something like it, was coming. The public and professional reactions fractured along predictable fault lines. Skeptics, including some prominent astronomers, dismissed the leak as an elaborate and sophisticated hoax. They pointed to the ease of digital forgery, the possibility of inside knowledge being used to fabricate convincing metadata, and the human propensity for seeing patterns in noise. They argued the structured jets could be a trick of image processing, a coincidence of transient features frozen in a single frame. The believers, however, saw a damning validation of long-held suspicions about classified space capabilities and government opacity. For them, the files were a smoking gun, proof that the true frontier of space exploration and observation is hidden behind a veil of national security, and that the objects entering our celestial neighbourhood are subject to a scrutiny the public is never allowed to see. But the debate between hoax and truth is, in many ways, a distraction. It is a binary trap. The far more important exercise is to sit with the questions the leak forces us to ask, regardless of its ultimate provenance. The central question, the one that echoes through every line of metadata and every pixel of the Oracle imagery, is the question of the 20-year gap. Why does the technology in the leak so perfectly mirror, in name, function, and orbital placement, a system proposed in an obscure academic paper from 2005? How could a dry conference presentation from 2 decades ago serve as a near-perfect blueprint for a secret surveillance network that just happened to be online for the arrival of the most anomalous interstellar object ever recorded? To answer that, we must leave the digital leak of 2025 and travel back in time to a conference hall in Valencia, Spain, to a presentation that nobody paid much attention to, a paper titled Cassandra. Its existence suggests the preparation for 3i Atlas did not begin with its discovery. It began when most of us were still using flip phones, and its authors were describing a future they seemed to already know. The year is 2005. The venue is the International Astronautical Congress in Valencia, Spain. The halls are buzzing with talk of the space shuttle's return to flight, nascent plans for what would become the Lunar Gateway, and the steady march of robotic explorers across Mars. Among the thousands of presentations, one paper is slotted into a modest session on planetary defense. Its designation is forgettable, IACA5 A3.507. Its title is dry, academic. Cassandra, a distributed sensor architecture for long-range threat characterization in the inner solar system. To the few who skim its abstract, it reads like speculative engineering, a thoughtful, perhaps overly ambitious proposal for defending Earth from asteroids. It is cited by almost no one in the following years. It fades into the immense dusty archive of conference proceedings, a relic of a moment when the future seemed more predictable. Yet 20 years later, this paper would become the Rosetta Stone for deciphering the 3i Atlas leak. Because Cassandra wasn't just a proposal, it was a blueprint, and when the leaked files emerged in 2025, they revealed a surveillance network that wasn't just inspired by Cassandra, it was Cassandra brought to life down to the most minute technical specifications. This is the academic paper that shouldn't exist, a document that reads less like a prediction and more like a preparation guide for an event 2 decades in the future. The Cassandra paper's authors were not the usual planetary scientists. The lead contributors were aerospace engineers and systems architects with backgrounds in a field notably absent from typical asteroid defense discussions: ballistic missile tracking and exoatmospheric interception. Their expertise was in detecting small, fast-moving objects against the complex backdrop of space, discriminating real threats from decoys, and maintaining continuous tracks through atmospheric interference and countermeasures. On the surface, they were applying this expertise to the problem of near-Earth objects, but a close read reveals their proposed system was grotesquely over-engineered for spotting city-killer asteroids. The paper proposed the deployment of what it called an Oracle-class sensor platform. Its recommended position was specific and deliberate, not low Earth orbit, not geostationary orbit, but the Earth-Moon Lagrange-point 1, ML1. The authors spent considerable text justifying this choice, noting that L1 offers a permanently stable vantage point with the Sun always at its back relative to Earth, allowing for continuous transit-based observation of the Sun-Earth line. In simpler terms, an object at L1 can use the Sun as a brilliant backlight, turning distant, faint objects into stark silhouettes. It is the perfect position for seeing something coming from the inner solar system, from the direction of the Sun itself. The leaked files from 2025 contain imagery tagged Oracle 6 EML1. The Roman numeral 6 implies a lineage, a series of predecessors. The designation is exact. The paper didn't stop at orbital mechanics. It delved into sensor specifications that in 2005 sounded like science fiction. It described a multispectral imaging array with simultaneous coverage across visible, infrared, ultraviolet and low-energy X-ray bands. The stated goal was to detect low-albedo NEOs, dark asteroids, but the technical details went far beyond simple detection. The proposed system would incorporate hyperspectral analysis modes capable of identifying specific molecular and atomic emission signatures at extreme ranges. It would track multiple independent targets simultaneously via partitioned sensor queues. It included schematic diagrams of the sensor layout, showing how an array of telescopic elements could be gimbaled and coordinated to provide unblinking coverage of a wide field of view. Compare this to the leaked Argus VIS system. The name itself is a direct echo. Argus, the all-seeing giant of Greek mythology. The leaked specs describe 256 simultaneous video streams with hyperspectral capabilities. The Cassandra paper described a system of distributed fault-tolerant sensor data ingestion capable of handling an exabyte-scale continuous feed. In 2005, the term big data was just entering the lexicon. The concept of managing data flows of that magnitude was the domain of a handful of intelligence agencies. The paper's database architecture reads like a precis for Apache Cassandra, the open-source distributed database system released in 2008, and now a backbone of the modern internet. The database was named for the mythological prophetess, but the congruence of names, purpose, and technical description between the 2005 paper and the 2008 software is jarring. Did the software engineers name their project after an obscure academic paper, or did the paper's authors describe a classified data architecture that would later be mirrored in the civilian world? Most telling were the passages that veered away from asteroids altogether. Tucked between equations and systems diagrams were discussions of non-gravitational perturbation detection and anomalous emission geometries. The authors theorized about objects that might exhibit structured plasma interactions with the solar wind, creating stable, non-isotropic coma formations. They argued that such objects would require specialized tracking protocols distinct from standard Keplerian solutions, meaning their paths couldn't be predicted by gravity alone. They even discussed the detection thresholds needed to spot an object at the cosmic background noise limit as it crossed the heliopause, the boundary of the solar system. Why would an asteroid defense system need to detect something at the very edge of the sun's influence, years before it became a threat? You wouldn't unless you weren't looking for asteroids. You would need that sensitivity if you were watching for something arriving from interstellar space, something you wanted to track from the moment it breached our cosmic doorstep. The benign interpretation of the Cassandra paper is that it was a work of extraordinary prescient genius. Its authors were visionaries who looked at the problem of planetary defense and conceived of the ultimate system, decades ahead of its time. They happened to guess correctly about technologies that would later become feasible. They happened to focus on L1, which later became an obvious strategic point. They happened to speculate about exotic object behavior that later manifested, a series of lucky intellectual strikes. The darker interpretation is harder to shake. What if Cassandra wasn't a prediction, but a disclosure? What if this group of engineers, with one foot in the academic world and another in the classified realm of missile defense, were tasked with a peculiar problem: to create a plausible, public-facing intellectual foundation for a system that already existed, or was already being built, for a different purpose? Publishing a detailed academic paper creates a paper trail. It establishes prior art. If decades later, a sophisticated space surveillance network is revealed, authorities can point to Cassandra and say, "See, it was proposed by researchers long ago, we just finally built it." It provides the ultimate cover for a long-running black program. The paper's dry academic tone isn't just for peer review, it's a form of camouflage, hiding a monumental truth in plain sight amidst differential equations and systems engineering diagrams. The Cassandra paper received no significant funding, spurred no public missions. It was by all external measures a dead end. Yet, every major component it described, the Oracle platform at L1, the Argus multispectral array, the massive-scale data ingestion architecture, appears in the 2025 leak as operational real-world hardware that captured an interstellar object behaving exactly as the paper's most speculative sections had hypothesized. This is beyond coincidence. This is alignment. It suggests that the 2-decade silence between the paper's publication and the arrival of 3i Atlas was not a period of inactivity, but of silent, determined construction. The blueprint was drawn in 2005. By 2025, the house was built, furnished, and waiting for its guest to arrive. This leads us directly to that house, to the silent sentinel hanging in the gravitational balance between worlds, the platform the leaks call Oracle 6, 60,000 kilometers above the Earth, along the invisible thread of gravity that connects our world to the Moon. There is a point of perfect balance. Here, the gravitational pull of Earth and the Moon cancel each other out, creating a stable pocket in space known as the Earth-Moon Lagrange-point 1, or EML1. It is a prime orbital parking spot. Satellites positioned here require minimal fuel to maintain station, as if resting in a cosmic cradle. It is an ideal location for observatories that need a constant, unwavering view of the Sun, like the Solar and Heliospheric Observatory, SOHO, or the Deep Space Climate Observatory, DSC-OVR. Their mission is public, scientific, benign, to study solar storms and image our planet. But the leaked files point to another resident at L1, one that does not appear on any public registry, a satellite hiding in the plain sight of a well-trafficked orbital neighbourhood. Its name, according to the metadata stamped on the imagery of 3i Atlas, is Oracle 6, and its existence, if real, transforms L1 from a scientific outpost into the ultimate spy post for the inner solar system. The advantages of L1 for the mission implied by the leaks are profound. From this vantage, you have a permanent, unobstructed view of the region between Earth and the Sun. Almost anything entering the inner solar system on a threatening or simply interesting trajectory will pass through this volume of space. But the Cassandra paper highlighted a more subtle advantage, the transit method. With the Sun directly behind it, an Oracle platform could use our star as the ultimate backlight. A distant dark object passing between the sensor and the Sun's brilliant disk would create a distinct silhouette. Even more importantly, any tenuous atmosphere or plasma envelope surrounding that object would be illuminated from behind, revealing its structure in exquisite detail against the solar corona. It is the astronomical equivalent of seeing dust motes in a sunbeam. This is precisely the geometry suggested in one of the most intriguing leaked diagrams, labelled Configuration 12, which shows Oracle 6 tilted and focused on a specific point in space, with annotations about optimal backlit geometry and a 7-hour intercept window. This wasn't passive observation, this was active, pre-planned interception of a target on a known path. Public data from the legitimate occupants of L1 contains curious intermittent anomalies. The data logs from SOHO and DSCOVA, available to scientists worldwide, occasionally note brief occlusion events, or transient shadows. These are usually dismissed as cosmic ray hits on the detectors, passing debris or instrument glitches. But a persistent minority of analysts have noted that some of these events cluster around times when unusual astronomical phenomena were occurring elsewhere, such as the close approach of long-period comets. The pattern is faint but suggestive, as if another, unlisted craft at L1 was periodically manoeuvring, its silhouette briefly drifting across the public sensor's fields of view as it repositioned to track something of interest. Furthermore, in 2022, the Air Force Research Laboratory publicly awarded a contract for a project called Oracle P. The unclassified summary described it as a next-generation space domain awareness platform for tracking objects in cislunar space between Earth and the Moon, with a planned launch in 2026. The stated purpose, tracking the increasing clutter of satellites and debris around the Moon, was logical and publicly acceptable, but the technical specs hinted at something more. They mentioned multispectral capabilities across 12 bands and detection thresholds calibrated for objects at lunar distances and beyond. Why would a satellite tracker need such exquisite sensitivity for objects so far away? The leaked files present two possibilities. First, that Oracle 6 is a fully operational classified predecessor to the publicly announced Oracle P, deployed years if not decades earlier. Second, and more disturbingly, that Oracle P was always intended as a cover story, a white program to explain the capabilities and funding of a black program that has been operational for years. The capabilities required to do what Oracle 6 allegedly did, track 3i Atlas with such detail from such a distance, are immense. It implies a telescope with a primary mirror, likely rivaling or exceeding that of Hubble, but paired with sensors far more advanced and a pointing stability perfected for tracking fast-moving targets. It implies a spacecraft with significant onboard data processing power and a high bandwidth, secure downlink to Earth. This is not a simple sensor package, it is a flagship-class intelligence asset. The 6 in its name suggests an evolutionary history. Oracle 1 through 5, whatever they were, prototypes, technology demonstrators, earlier operational models, are ghosts in the machine, unseen chapters in a classified history of space surveillance. The most compelling reason to place such a powerful sensor at L1, specifically for the mission the leaks imply, is warning time. The solar system is enormous. The heliopause, where the solar wind gives way to interstellar medium, is about 18 billion kilometers away. An object entering the solar system from interstellar space, travelling at a typical velocity of 20-30 kilometers per second, would take years to journey from that boundary to the inner solar system where Earth orbits. If you could detect an object as it crossed that threshold, you could have years, perhaps a decade or more, of advance notice. From L1, with a sensor capable of the cosmic background noise limit detection the Cassandra paper described, you might just be able to do that. You could see the ripples in the interstellar medium before you saw the stone. If you knew something was coming, L1 is where you would put your sentinel to watch for its first appearance against the sun. The leaked imagery of 3i Atlas, showing it in stunning detail with its bizarre plasma jets, suggests Oracle 6 wasn't just casually scanning the sky. It was locked on, tracking a target of pre-existing interest. It was fulfilling a mission profile 2 decades in the making, but a platform is only as good as its eyes. And the eyes of Oracle, according to the leaks, belong to a system whose very name speaks of omnipresent vigilance, Argus Vis. In Greek mythology, Argus Panoptes was a giant with 100 eyes, an ever-watchful guardian. In the early 21st century, DARPA, the Pentagon's advanced research agency, brought the myth to life with Project Argus, a staggering surveillance system for unmanned aerial vehicles. Using a 1.8 gigapixel camera array, the original Argus could simultaneously track every moving vehicle and person across an entire medium-sized city, storing petabytes of video and enabling analysts to rewind time on any square foot of urban terrain. It was a god's-eye view made terrifyingly real. The leaked files from 2025 suggest that this concept didn't stop at the edge of the atmosphere. It was scaled up, hardened, and launched into the void. Argus Vis, as described in the metadata, appears to be what happens when you take the principle of total situational awareness and apply it to deep space. It is not merely a camera pointed at a comet. It is a panopticon built for the cosmos, and its alleged target was 3i Atlas. The specifications hinted at in the leaks are staggering. Where the original Argus had 368 camera modules for 1.8 gigapixels, the space-based Argus Vis is described as managing 256 simultaneous independent video streams. This isn't just 256 cameras taking the same picture. This is 256 distinct imaging channels, each potentially tuned to a different slice of the electromagnetic spectrum, all focused on the same target or distributed across a field to track multiple targets. More critically, the system is described as hyperspectral. A standard camera sees in 3 broad bands: red, green, blue. A multispectral imager might see in a dozen. A hyperspectral imager sees in hundreds of extremely narrow contiguous bands, creating a detailed fingerprint of light for every pixel in the image. It can distinguish between types of rock, ice, metal, and gas based on the unique way they reflect or emit light. Argus Vis, therefore, wouldn't just show what 3i Atlas looked like. It would deconstruct its very essence, identifying the molecular composition of its nucleus, its coma, and those strange plasma jets in real time. This level of scrutiny is gross overkill for a normal comet or asteroid. Once you've determined an asteroid's orbit and rough composition, your job is largely done. You don't need hundreds of simultaneous spectral channels watching its every move. You would only need such an overwhelming, redundant, and analytically deep sensor suite if you were observing a target that might do something unexpected at any moment. A target whose behavior was fundamentally unpredictable and whose every emission might contain critical data. You would need it if you were watching for anomalous emission geometries and non-gravitational perturbations of the exact kind the Cassandra paper discussed and that 3i Atlas exhibited. The leaks suggest Argus Vis was the primary sensor that captured the most puzzling aspects of 3i Atlas's behaviour. The sudden brightness jumps, those discrete luminosity increases, would have been recorded across all 256 spectral channels simultaneously. Scientists could see not just that it flared, but how it flared. Did the infrared spike first, indicating a sudden release of heat? Or did the ultraviolet indicating a burst of high-energy processes? Did the cyanogen emission lines, the source of the green glow, intensify uniformly, or did one jet brighten before the others? This data would be a Rosetta Stone for understanding the object's mechanics. Furthermore, Argus's alleged ability to track micro-variations in coma shape would be key to analysing the object's most shocking feature, its structured plasma envelope. Normal cometary comas are messy, expanding clouds of gas and dust. Solar radiation pressure and the solar wind blow this material outward into a roughly symmetrical but dynamically chaotic blob. The plasma, ionized gas, within this coma is turbulent. What Argus Vis reportedly saw around 3i Atlas was different. The plasma appeared organized into stable concentric shells, and those 4 iconic geometric jets. Hyperspectral data could determine if the composition of the inner shell differed from the outer shell, or if the jets were made of different material than the background coma. This is critical evidence. Natural outgassing from a lumpy, rotating nucleus would produce a mixed, homogeneous coma. A structured, layered envelope suggests different release mechanisms or active confinement, perhaps by magnetic fields. This connects directly to the other great anomaly, the non-gravitational acceleration. Comets experience this when outgassing acts like a weak rocket engine, but the force typically pushes directly away from the Sun, the source of heat. Analysis of 3i Atlas's trajectory based on public data shows its deviation is not only too large for standard cometary outgassing, but the push seems to be coming from the side, a lateral nudge. Some researchers have cautiously floated the idea of a plasma sail effect. If the object can generate or shape magnetic fields, its structured plasma envelope could interact with the solar wind, the stream of charged particles from the Sun, to produce thrust, much like a sailboat catching the wind. The direction of that thrust depends on the sail's orientation, not just the heat from the Sun. Argus Vis, with its ability to map plasma density and structure in extreme detail, could confirm or deny this. It could see if the plasma jets were aligned in a way consistent with creating a magnetic bubble, a makeshift propulsion system. The existence of Argus Vis as described transforms 3i Atlas from a curiosity into a laboratory. Every strange characteristic becomes a data point captured in multidimensional detail. But it also raises a more profound question. Why build this? Why pour decades and untold billions into creating a space-based Argus, a hyperspectral panopticon watching the interstellar frontier? The only conceivable answer is that its builders expected to find something worth watching with such fanatical detail. They built a microscope for the sky, anticipating a specimen that would require it. The Cassandra papers focus on field-interacting bodies, a non-standard emission, reads like the user manual for Argus Vis's intended target. This alignment of prediction and capability over a 20-year gap is the core of the mystery. It points to a period of silence, not of idleness, but of secret construction and waiting. The systems were built. Then they waited for 2 decades. The timeline between the Cassandra paper in 2005 and the leak in 2025 is a chasm of public silence. In the open, little happened. No major space agency adopted Cassandra's proposals. The authors published no significant follow-ups. The paper gathered digital dust. Yet, beneath this placid surface, the evidence suggests a parallel hidden timeline was unfolding, one of funding, construction, deployment, and silent vigilance. This 20-year silence is not an absence of data. It is, in itself, a form of data. It is the shape of a secret. To understand why it's breaking now, we must walk through the shadow history of those 2 decades, a history written not in press releases but in budget anomalies, industrial rumours, and the careful whispers of those on the inside. The first subtle tremor might have occurred around 2012. Buried in the labyrinthine appendices of Department of Defense budget documents was a line item for space situational awareness architecture enhancement. The funding was notable not for its size. It was deliberately kept below the threshold requiring detailed congressional reporting, but for its description, which emphasized persistent deep space tracking and sensor fusion for non-standard trajectories. Around the same time, aerospace contractors began hiring for specialties that seemed oddly specific: hyperspectral data fusion for low-signature targets, and orbital mechanics for hyperbolic trajectories. These were niches within niches, suggesting the development of tools for a very particular problem: finding faint, fast-moving objects that don't obey normal orbital rules, the hallmark of interstellar interlopers. The period from 2016 to 2020 saw another surge. Publicly, this was the era of the Space Force's creation and a new focus on cislunar domain awareness. The unclassified narrative was about protecting assets near the moon, but the classified annexes of budgets, whose contents are summarized in vague paragraphs, reportedly contained massive allocations for advanced optical payloads and long-duration autonomous space platforms. Industry forums frequented by retired engineers began to see murmured references to a long-duration L1 resident that wasn't SOHO or Dieskova. The comments were never explicit, always couched in hypotheticals or what-if scenarios. If you were to put a big eye at L1, one comment read in 2018, the calibration routines for dealing with solar coronal interference would be a nightmare, but the payoff for early warning would be unprecedented. These were the careful words of people who knew something but could not say it. Then came 2024, the year before the storm. In podcasts and niche seminars focused on the future of space exploration, a new theme emerged from certain speakers with backgrounds in intelligence or defense contracting: the concept of interstellar object anticipation. They spoke not of discovery, but of expectation. They discussed models suggesting the influx of such objects might be higher than predicted, and that some might exhibit techno-signatures, not necessarily proof of intelligence, but signatures requiring technology to produce. The language was academic, but the subtext was clear. A segment of the insider community was being softly prepared, or was preparing itself for a shift in paradigm. All of this clandestine activity culminated in the autumn of 2025. 3I Atlas was publicly discovered. It performed its perihelion passage, and then, crucially, after it had survived its close brush with the Sun and begun exhibiting its anomalous brightening jumps, the leak happened. This timing is everything. A leaker needs credibility. Releasing files before perihelion would be a gamble. The object could disintegrate, proving the interception narrative false. Releasing them after, when the object was not only real but behaving strangely, provided irrefutable validation. The leak didn't just show classified data, it showed classified data of an object that the public now knew was genuinely weird. It gave the leak instant, undeniable weight. So why would such a profound secret be maintained for 20 years, only to be blown open now? Several rational motives exist. National security is the foremost. The technological edge afforded by systems like Oracle and Argus is monumental. Revealing them would invite adversarial countermeasures and spark an arms race in deep space surveillance that could destabilize the fragile orbital environment. Avoiding public panic is another. An official announcement in, say, 2010 that a strange interstellar object was due to arrive in 2025 and might exhibit artificial characteristics would have caused global upheaval, societal, religious, and scientific. Secrecy allows for controlled private study and assessment of any potential threat or opportunity. Geopolitical advantage is a third. In an era where China and Russia are actively developing anti-satellite weapons, possessing the ability to track objects at interstellar distances is a demonstration of supreme technological prowess, a silent deterrent. But there is a more speculative motive that fits the peculiar predictive nature of the Cassandra paper. What if the secrecy wasn't just about protecting technology or preventing panic? What if it was about protecting a timeline? What if a small, compartmentalized group within the defense and scientific establishment didn't just hope to see an object like 3I Atlas? They knew it, or something like it, was on a schedule. This knowledge could have come from extrapolating the paths of earlier, fainter precursors detected by even more secretive means. It could have come from an analysis of gravitational wave background patterns or interstellar medium disturbances that hinted at regular traffic. Or it could have come from something else entirely. If you have such foreknowledge, measured in decades, you build the tools to meet the moment. You do it in secret because the source of your knowledge might be as sensitive as the knowledge itself. The 20-year gap between blueprint and event isn't a paradox, it's the project schedule. The leak then may represent the rupture of this sealed timeline. It could be the work of a lone whistleblower who believed the truth outweighed the risks. More likely, given the sophistication of the leak, it represents internal factional pressure. The intelligence world is not a monolith. One faction, perhaps aligned with traditional need-to-know secrecy, would want the 3i Atlas data buried forever. Another faction, perhaps influenced by a growing philosophical belief in cosmic transparency or by the practical need to leverage broader scientific expertise, might have pushed for disclosure. The leak could be their weapon, a way to force the data into the open by creating an undeniable public controversy. The silence is broken because the waiting is over. The predicted object arrived. It behaved as anticipated, or perhaps even more strangely. The secret sensors worked. The data is immense and troubling. The internal debate over what to do next, to bury it deeper, or to begin a controlled release, may have sparked the conflict that led to the leak. We are now witnessing the first tremors of that conflict reaching the public shore. But to fully understand why this object might have been anticipated, we must confront an even more unsettling possibility, that 3i Atlas was not the first, that it is merely the first one we were meant to notice. This leads us to the precursor theory, and to the question of what else might be hiding in our own astronomical archives. If 3i Atlas was the meticulously observed guest of honour at a secret decades-long surveillance operation, a haunting question emerges. Was it truly the first to arrive? Or is it simply the first to arrive under the full focused glare of the Oracle and Argus systems? The first whose strangeness was too obvious to ignore? This is the precursor theory, the idea that 3i Atlas is not a unique singularity, but the most recent and vivid example of a phenomenon that has been occurring for far longer than publicly acknowledged. It suggests our solar system may be experiencing a faint, steady drizzle of interstellar anomalies, most of which pass through unseen or misclassified, with 3i Atlas being the spectacular droplet that finally hit the lens. To examine this, we must sift through the archives of modern astronomy, through the transients and anomalies that defy easy explanation, events often logged with a shrug and filed away as instrumental glitches or unsolvable curiosities. The first significant precursor event flagged by retroactive analysis occurred in 2009. The Pan-STARRS Survey Telescope in Hawaii, a workhorse for detecting near-Earth objects, recorded a brief, unexplained brightening in a patch of sky devoid of known stars or asteroids. The transient designated Siasen Rho 9XJ lasted approximately 6 hours. Its spectrum, captured in a single low-resolution snapshot, showed a curious excess of emission in the green wavelengths, consistent with the ionogen radical, a common cometary gas. Yet, there was no known comet in that region. The event was logged as a likely fragmentary disruption of an unknown minor body, and forgotten. But cyanogen emission is now a hallmark of 3i Atlas's green plasma jets. Could Pythian, a SNXJ, have been a smaller, fainter object of similar composition, passing quickly through the survey field, outgassing in a brief structured burst before vanishing into the darkness? In 2013, a more puzzling event was captured by the Catalina Sky Survey. Designated CSS 1223, it was initially tagged as a satellite glint, a reflection of sunlight off a tumbling piece of space debris. But the spectrum was all wrong. Mixed with the reflected sunlight were sharp, bright emission lines of ionized nickel. Nickel lines are signatures of high-energy processes, supernova remnants, solar flares, or extremely hot plasma. They do not appear in the gentle reflection of sunlight off a passive cold rock or a piece of spacecraft aluminum. The object was tracked for 4 hours before it moved out of the field of view, its trajectory uncertain. The official report concluded with unknown origin, possibly man-made space debris with anomalous material properties. But the ionized nickel signature eerily presages the complex energetic plasma chemistry observed around 3i Atlas. The most compelling precursor came in 2018. An object temporarily designated a 2018 U5 was detected by multiple observatories across 3 continents. At first, it was classified as a fast-moving asteroid. Then, a faint coma was noticed, prompting a reclassification as a comet. But its light held a strange quality. Polarimetry, the study of how light waves are oriented, revealed a pattern that baffled scientists. the light reflecting from A2018 U5 was highly and unusually polarized, and that polarization changed in a rapid, repeating cycle over 8 hours. This suggested a surface or surrounding dust cloud that was not just irregular, but actively changing its structure in a regular, perhaps rotating pattern. Natural comet nuclei can produce complex polarization, but not with such a clear cyclical evolution. The objects sped away before dedicated follow-up could be arranged, leaving behind a tantalizing, incomplete dataset. Its polarization behavior now finds a distant cousin in the structured shell-like plasma envelope of 3I Atlas, which would also dramatically affect the polarization of sunlight passing through it. These 3 events, the 2009 cyanogen flash, the 2013 nickel line glint, and the 2018 polarization anomaly, share a common thread with 3I Atlas. They each exhibit one piece of its bizarre portfolio. Alone, each was a curious outlier. Together, viewed through the lens of the 2025 leak, they sketch a pattern. They suggest that objects exhibiting unusual spectral features, non-standard outgassing, or structured interactions with light have been passing through our inner solar system for at least a decade and a half. They were seen but not understood, detected but not recognized as a class. This pattern grows more intriguing when cross-referenced with another, more clandestine dataset, scheduled maintenance blackouts of classified space surveillance assets. The US Space Surveillance Network, SSN, a global array of radar and optical sensors used to track orbiting objects, periodically takes systems offline for calibration and upgrades. These blackout windows are not publicized, but their occurrence is known to careful observers. The 2009 Pan-STARRS event occurred during a 12-hour blackout of key Northern Hemisphere SSN radar fences. The 2013 Catalina event happened 72 hours after a documented gap in data from several key tracking satellites in geosynchronous orbit. The 2018 polarization anomaly coincided almost exactly with the sensor recalibration period, affecting multiple Space Force optical tracking stations. Coincidence is the simplest explanation. Maintenance schedules are planned months in advance, and astronomical transients are random. But if one assumes the existence of a classified deep space tracking grid, like the one implied by the Oracle leak, a darker pattern emerges. What if these blackouts weren't coincidental? What if they were operational security measures? If your secret Oracle platform at L1 or a clandestine tracking telescope on the ground was actively observing one of these anomalous precursors, you would not want its data collection to be correlated with public sensor blackouts. So, you would take your public tracking assets offline as well, creating a blanket maintenance window that masks the fact that your classified assets are the only ones watching at that moment. The transient appears in public astronomical data, but the simultaneous, more detailed classified data remains secret, and the temporary blindness of public military trackers helps hide the fact that someone else was looking. The precursor theory fundamentally alters the timeline of the Cassandra program. It provides a compelling reason for a 20-year development cycle. You don't build a system of Oracle and Argus's sophistication based on a single theoretical prediction. You build it because you've seen hints. You build it because something strange happened in 2009, and again in 2013, and again in 2018. Each event, perhaps detected by earlier, cruder iterations of the surveillance network, Oracle 2, Oracle 3, provided more data, more urgency. The program evolves from pure hypothesis to confirmed intermittent phenomenon. The final mature system, Oracle 6 and Argus Vis, is then online and waiting when the biggest, most unambiguous signal yet arrives, 3I Atlas. The 20-year gap isn't about waiting for one predicted object. It's about iteratively building a capability to study an emerging pattern of interstellar anomalies. If the precursors are real, then 3I Atlas is not a beginning, but a culmination. This theory also hints at a staggering possibility: regularity. The galaxy is vast and empty. For multiple objects with similar anomalous characteristics to enter our small solar system within a 15-year period stretches the laws of random chance. It suggests these objects may not be randomly drifting. They could be traveling along preferential pathways, gravitational currents, or even something more structured. Their arrivals might have a rhythm, a cadence that the analysts of the Cassandra program began to discern. This leads directly to the most concrete and measurable anomaly of 3I Atlas, one that separates it from mere strange composition or appearance. It doesn't move the way it should. Its path through space defies the simple, reliable pull of gravity alone, pointing to forces at work that we are only beginning to fathom. Gravity is the great clockmaker of the cosmos. Its rules are simple, universal, and unforgiving. Given the mass of the Sun and the position and velocity of an object, we can plot its path centuries into the future or past with astonishing accuracy. This is how we navigate probes to distant worlds and predict the return of comets like clockwork. When an object deviates from this gravitational path, it is called non-gravitational acceleration. For comets, this is common and understood. Sunlight heats icy surfaces, causing jets of vaporizing gas to act like tiny, uneven rocket engines, nudging the comet off its purely gravitational course. The key is that these nudges are small, and their direction generally points away from the Sun, the source of the heat. 3I Atlas exhibits non-gravitational acceleration. This in itself is not proof of anything extraordinary, but the magnitude and, crucially, the direction of its deviation are where the laws of known physics begin to strain. By the time 3I Atlas reached its closest point to the Sun, it had deviated from its predicted gravitational trajectory by approximately 1.1 million kilometers. To put that in perspective, that's nearly 3 times the distance between the Earth and the Moon. This is not a small nudge. This is a substantial, sustained push acting over months of its approach. More critically, the vector of this push, the direction the force was applied, does not align with the Sun. Standard outgassing should push the comet directly away from the solar heat source. The acceleration on 3I Atlas, however, has a strong lateral component. It's as if, in addition to being pushed away from the Sun, it is being given a consistent shove to the side. This is profoundly unusual. It implies the forces acting on it are not simply the result of asymmetric heating on a tumbling ice ball. The propulsion mechanism, whatever it is, appears to be directional and possibly controllable. Scientists have scrambled for natural explanations. Perhaps the nucleus has an extremely unusual shape, like a flat plate, channeling gas jets in a focused off-axis direction. Perhaps it contains deep, cavernous vents that create jet effects like a poorly balanced lawn sprinkler. Perhaps its rotation axis is tilted in such a way that the rocket effect points sideways. All are possible, but all struggle to account for the sheer size of the deviation. The energy required to produce a 1 million-kilometer shove via simple sublimation of ice is immense, suggesting outgassing rates far beyond what is observed. The spectral data from 3I Atlas shows plenty of gas, but not that much. There is a disconnect between the observed activity and the observed motion. This is where speculation grounded in real physics enters, the plasma sail hypothesis. It is a theoretical propulsion concept for interstellar travel. A spacecraft generates a powerful magnetic field, inflating it into a vast invisible bubble. This magnetic bubble then interacts with the solar wind, the constant stream of charged particles flowing from the Sun. Just as the wind pushes a sailboat, the solar wind pushes against the magnetic bubble, creating thrust. This requires no onboard fuel, only a way to generate the magnetic field and the knowledge to shape it. The thrust direction depends on the orientation of the magnetic sail, relative to the solar wind, not necessarily on the direction of sunlight. You could, in theory, generate lateral thrust. Now, examine the observed facts of 3I Atlas. It possesses a massive structured plasma envelope. Ionized gas. The 4 cardinal jets could be the visible manifestations of a magnetic containment structure, points where plasma is funneled and focused. If this plasma is magnetically controlled, then the entire envelope could be interacting with the solar wind. The observed non-gravitational acceleration, with its puzzling lateral component, fits the plasma sail model far better than the simple rocket model of cometary outgassing. The object could be using the Sun's own output, the solar wind, for propulsion, perhaps for course correction or stabilization. This is not proof. It is a hypothetical framework that fits the anomalous data more neatly than standard comet models. This concept was chillingly prefigured in the Cassandra paper. In a section discussing field-interacting bodies, the authors theorized about interstellar objects that might couple to ambient galactic and solar magnetic fields, leading to trajectory perturbations inconsistent with point source outgassing models. They wrote that such objects would require continuous vector tracking to distinguish natural sailing effects from guided acceleration. The language is careful, but the prediction is precise. Objects that move not just from gravity and outgassing, but from an interaction with magnetic fields and plasma. 20 years later, that is exactly the puzzle presented by 3I Atlas's flight path. The implications are tectonic. If the plasma sail hypothesis has any merit, it suggests 3I Atlas is not a passive piece of cosmic debris. It suggests an active interaction with its environment. It may not be propelled in the sense of having engines, but it may be engineered to harness natural forces in a way that alters its path. This moves the discussion from what is it made of to what is it doing, and what is it doing leads us back to the most visually stunning and technically baffling of its features, the plasma envelope itself. This is not just a cloud of gas, it is a structured, layered, persistent architecture surrounding the object, and it holds the keys to understanding everything else. The coma of a comet is its atmosphere, a temporary halo born from chaos. Solar radiation strikes the nucleus, blasting away molecules and dust in a violent, unpredictable spray. The solar wind, a supersonic stream of charged particles, then blows this material outward, creating a teardrop-shaped cloud that is, at a fine scale, a churning, turbulent mess. Structure is fleeting, smeared away by rotation, shifting solar heat and magnetic turbulence within seconds or minutes. This is what every cometary encounter from Halley to Hale-Bopp has shown us. The plasma envelope of 3I Atlas, as revealed in the leaked Oracle imagery and corroborated by subsequent difficult ground-based observations, defies this chaos. It is not a smear. It is an organised, multi-layered construct that has maintained its coherence over weeks of observation. This stability is perhaps its most scientifically shocking characteristic. Detailed polarimetric studies conducted in late 2025 revealed the envelope's architecture. The light scattered by the coma showed that the plasma is arranged in distinct concentric shells. An inner shell, close to the nucleus, composed of fine dust and neutral gas. A middle shell showing signatures of more energetic, ionized particles, and an outer shell, the most enigmatic, which exhibited polarization patterns that didn't match any known model of cometary dust or gas. These shells were not blurring into one another, they appeared as separate zones like the layers of an onion. Even more stunning, the 4 cardinal plasma jets maintained their geometric alignment and coherence as they pierced through these shells like pillars supporting a strange cathedral. This persistence is physically bizarre. The solar wind pressure varies by the hour. The comet's own rotation should twist and distort any large-scale structure. New outgassing from the nucleus should inject disorder. For these shells to hold their shape for days on end suggests a stabilizing influence, a force that actively maintains order against relentless natural pressures to dissolve into chaos. The Cassandra paper's most eerily specific section discussed interstellar field interacting bodies and their potential plasma morphology. The authors proposed that objects spending eons traversing the magnetic fields of interstellar space could develop organized magnetospheric sheaths, or charge-separated plasma layers, that might persist upon entering a solar system. They included a theoretical graph, Figure 7, plotting predicted emission intensity against distance from the nucleus for a magnetically structured coma. When astronomers compared this 20-year-old theoretical curve to the actual observed brightness profile of 3I Atlas's coma in 2025, the match was unsettlingly close. It wasn't perfect, but the predicted bulge of emission at a certain distance, the steep drop-off, the layered appearance, all were there. Either the paper's authors made an astronomically lucky guess about a phenomenon no one had ever seen, or they were working from a theoretical model informed by something more than pure speculation. 3 interpretations stand in stark opposition. The first is purely natural, rare physics. Perhaps interstellar objects, forged in alien systems and subjected to eons of deep space radiation and magnetic fields, simply behave differently. Their internal structure, their ice chemistry, the way they hold electrical charge, could all be alien enough to produce these stable plasma shells through some novel but natural magnetohydrodynamic process we've never witnessed. The universe is vast, and we have a sample size of 3 confirmed interstellar visitors. Unusual does not mean unnatural. The second is semi-natural engineered conditions. This is a subtler, more troubling idea. Perhaps the object itself is natural, a chunk of icy matter, but it has been modified or shaped by its environment or history in a way that creates these effects. Perhaps it passed through an intense interstellar magnetic field that imprinted a current loop within it, turning it into a simple, natural electromagnet. Perhaps its journey charged its surface to extremes, creating a persistent electrostatic field that organises its outgassing. This would be a natural object behaving in an unnatural way due to extraordinary prior conditions. The third interpretation, the one that exists at the frayed edge of scientific discourse, is engineered plasma shaping. If you were designing an interstellar probe, something meant to survive a million-year voyage, you would want a protective shield. A cloud of plasma held in a structured magnetic bubble would be ideal. It would deflect cosmic rays, absorb micrometeoroid impacts and manage thermal loads. The inner shell for physical buffering, the middle shell for radiation absorption, the outer shell for interacting with the solar wind, perhaps even for propulsion via the plasma sail effect. The geometric jets could be exhaust vents or field stabilizers. In this scenario, the plasma envelope is not a symptom, it is a system. This does not prove the object is a spacecraft, but it establishes a hypothetical framework where the observed features align perfectly with a theoretical design for one. Another anomaly compounds the mystery, the brightness-water paradox. Observations from the James Webb Space Telescope during the comet's approach measured the amount of water vapor in its coma. Comets brighten primarily because sunlight reflects off increasing amounts of released dust and gas. More water vapor usually means more dust and brighter light. For 3I Atlas, the math didn't work. It was significantly brighter than the measured amount of water vapor could explain. Where was the extra light coming from? One answer lies in the plasma itself. If the envelope is energized, if electrical currents are flowing through it, or if it's the site of magnetic reconnection events, it could be generating its own light, a process called synchrotron radiation, or ion recombination emission. This light would be additive, making the object brighter without requiring more water ice. This, again, points to an active energetic process within the coma, not just passive reflection of sunlight. The classified Argus Vis data, if it exists as leaked, would be the definitive arbiter. Its hyperspectral eyes could map the temperature, density, and magnetic field strength within each shell of the plasma envelope. It could detect currents, pinpoint energy sources, and distinguish between thermal glow and artificial emission. That data remains behind the veil. Its absence forces us to work with shadows and implications. And one of the most compelling implications from the leaked files is that the Oracle platform didn't just watch from a distance. It may have performed a carefully choreographed maneuver to get the best possible view, an operation that suggests not just observation, but a planned scientific intercept. Among the leaked technical diagrams, one stands out for its operational specificity. Labelled Configuration 12, Intercept Geometry, and dated 9 months before the official discovery of 3I Atlas, it shows the Oracle platform at L1 not in its standard surveillance orientation, but canted at a precise angle. Trajectory lines overlay the diagram, marking the path of an incoming object from the galactic plane. Annotations calculate optimal backlit geometry, minimal solar interference, and most critically, intercept window duration, 7 hours. This was not a passive observation plan. This was a mission profile. It describes positioning the satellite to use the sun as a perfect backlight during a narrow, pre-calculated window when 3I Atlas would pass through a specific point in space. This is the maneuver of an observer who knows exactly where and when their subject will be. It is the action of a hunter, not someone who just stumbled upon prey. An L1 intercept in this context doesn't mean a physical rendezvous. It means placing your sensor in the perfect spot to conduct the most revealing observations possible. The backlighting technique is supremely powerful. With the sun directly behind Oracle 6 and the comet in between, even the most tenuous, transparent structures in the plasma envelope would be thrown into stark, high-contrast relief. Density variations, gaps, magnetic field lines made visible by aligned dust, all would be revealed. It's the difference between looking at smoke in a room and seeing that same smoke lit by a bright window. The diagram proves intent and foreknowledge. It indicates that the trajectory of 3I Atlas was known with precision nearly a year before the public announcement, allowing for complex orbital choreography at L1. Unverified rumours that have swirled in the same aerospace forums that first hinted at a secret L1 resident add another layer. These rumours suggest that during this intercept window, Oracle 6 detected more than just light. It allegedly recorded an unusual, non-natural electromagnetic emission in the radio spectrum, coincident with one of the object's brightness jumps. The signal was described as structured but non-linguistic, showing clear, repeating patterns, modulation, and bandwidth characteristics that distinguished it from cosmic noise or known spacecraft transmissions, but which did not form a decodable language or pattern akin to human communication. It was a signal, not necessarily a message. These rumours are impossible to confirm, but they fit a pattern of escalating strangeness and suggest the object's activity may not be confined to the visual spectrum. The intercept hypothesis makes the absence of any public mission proposal to visit 3I Atlas all the more deafening. After Oumuamua's discovery in 2017, there was an immediate, passionate push from the scientific community to design a fast intercept probe, yielding concrete, though unfunded, mission concepts like Project Lyra. For 3I Atlas, a larger, brighter, and far more anomalous object, the public discourse has been curiously muted. No space agency has announced even a feasibility study for a rendezvous. The official reason is the same: it's too fast, we found it too late. But the leaked Configuration 12 diagram suggests that for someone, it wasn't too late at all. They were ready. The silence on the public side may imply that the relevant stakeholders already have the data they need, acquired from a distance no publicly acknowledged spacecraft could match. This accumulation of anomalies, the foreknowledge, the structured plasma, the non-gravitational acceleration, the potential EM emissions, coalesces into a theory so controversial it is rarely spoken aloud in mainstream circles. It is the theory that 3I Atlas is not a visitor, nor even a probe in the traditional sense. It is a beacon. The beacon hypothesis distinguishes itself from the idea of an intelligent probe. A probe explores, gathers data, makes decisions. A beacon's function is simpler: to be noticed. It marks, indicates, or transmits. The geometric plasma jets could be a purposeful signature, a pattern designed to stand out against the natural chaos of the cosmos. The periodic brightness jumps could be timed pulses. The stable plasma shells could be a durable lighthouse lens focusing emission. Its anomalous trajectory could be a way to flag its artificiality, as natural objects rarely get such a pronounced sideways kick. A beacon doesn't need to be smart. It needs to be obvious and durable. It could be an ancient piece of technology, a milepost left by a civilization long gone, signalling the location of our star system on a galactic map. Or it could be a more recent marker, indicating something about this region of space or this moment in time. The final section of the Cassandra paper, often overlooked, discussed non-biological informational carriers. The authors mused about objects that could convey information through persistent physical or emissive state, rather than dynamic computation. They used the analogy of a crystal storing data in its lattice structure, or a pulsar broadcasting a regular timing signal. An interstellar beacon, they theorized, could encode information in the spacing of its emission pulses, the ratio of gases in its jets, or the specific geometry of its structure. 3I Atlas, with its fourfold symmetry, its layered shells, and its irregular but patterned brightening, fits this description uncannily well. The paper's title itself, Cassandra, the prophetess no one believed, takes on a meta-meaning. Was the paper itself a beacon, warning of the beacons to come? None of this constitutes proof. Nature is endlessly inventive and coincidence is a powerful force. Yet the convergence of a 20-year-old predictive paper, a leaked surveillance network of impossible capability, and an object exhibiting a suite of highly anomalous interlocking characteristics creates a pattern that demands explanation beyond mere chance. The final pieces of this pattern are now falling into place not from leaks, but from public scientific breakthroughs in late 2025. Breakthroughs that provide the technological and cosmic context for why all of this might be happening now, and how we might finally begin to see the full picture. December 2025. As 3I Atlas recedes into the outer darkness, its legacy is not fading but intensifying, catalyzing a series of seemingly unrelated scientific breakthroughs that together form a new cosmic context. These aren't leaks. They are peer-reviewed announcements, public patents, and data releases. Independently, each is revolutionary. Viewed through the lens of the 3I Atlas mystery, they appear as pieces of a puzzle assembling itself, providing the tools and the map to understand what we may be facing. This is no longer just about one object. It is about humanity developing the senses to perceive a galaxy that may be far more structured, active, and perhaps even populated than we ever dared imagine. The first breakthrough is in quantum sensor networks. In mid-December, a NASA-DARPA collaboration announced the successful demonstration of stable quantum entanglement between photons over a distance matching the Earth-Moon separation, the precise scale of the L1 region. Quantum entanglement allows for what's called quantum baseline interferometry. By comparing the quantum states of entangled particles at two separate sensors, you can detect incredibly faint disturbances in the space between them with a sensitivity that crushes classical physics limits. The public release touted applications in precision gravity field mapping and ultra-faint asteroid detection, but the classified potential is staggering. A network of such sensors, positioned at Lagrange points or on deep space probes, could create a solar system-wide spiderweb of sensitivity. It could detect the minute gravitational or magnetic ripples caused by an object crossing the heliopause, years before it's optically visible. It could distinguish a dense rock from a structured plasma envelope by the way it subtly warps spacetime or interacts with quantum fields. This technology, in prototype form, could have been the cosmic background noise limit sensor the Cassandra paper dreamed of. If deployed even in a rudimentary form years ago, it could have provided the decade-advance warning that explains Oracle's preparedness. The second is a landmark in gravitational wave astronomy. New results from the combined LIGO, Virgo, and the space-based LISA Pathfinder Consortium have produced the first detailed directional map of the gravitational wave background, the constant hum of spacetime from countless cosmic collisions across the universe. The map revealed something unexpected. The hum isn't uniform, it has hotspots, specific directions in the galaxy where the signal is stronger. Theorists suggest these are regions dense with binary neutron stars or primordial black holes. But a minority analysis, published as a provocative note added, pointed out a curious correlation. The inbound trajectories of both Oumuamua and 3I Atlas, when traced back thousands of years, originate from the general vicinity of two of these gravitational wave hotspots. The odds of a random alignment are low. This suggests these interstellar objects may be travelling along cosmic highways defined by galactic gravitational structure, or perhaps that the sources of the gravitational waves and the origins of the objects are linked in some deeper way. The galaxy may not be a random scatter of stars, it may have flows, currents, and lanes of heavier traffic. The third breakthrough is in plasma physics, directly addressing the mystery of 3I Atlas's envelope. A team analysing decades of data from the Voyager probes at the heliopause published a paper on what they term dark plasma states. They found moments where particle detector counts and magnetic field readings didn't match, suggesting the presence of a charged but weakly interacting plasma, a sort of stealth, magnetized medium. This dark plasma, they theorize, could form stable, long-lived structures in the turbulent boundaries of stellar systems. Immediately, physicists made the connection. The stable, layered shells around 3I Atlas could be a manifestation of dark plasma, a natural but previously unknown state of matter that self-organizes. The more speculative leap, noted cautiously in the paper's conclusion, is that such a medium would be ideal for constructing durable, low-energy plasma architectures in space, precisely the kind that might serve as a protective shield or a structural scaffold for a long-duration interstellar object. The final piece comes from artificial intelligence. New machine learning algorithms set loose on petabytes of archived Sky Survey data have identified not one or two, but 12 previously overlooked objects from the past 15 years that exhibit 3I Atlas-like anomaly signatures. One showed a brief cyanogen spike, another had unexplained lateral acceleration, a third displayed unusual infrared properties. None were as bold or comprehensive as 3I Atlas, but the pattern is now statistically significant. The AI suggests these kinds of anomalous interstellar interlopers may pass through the inner solar system at a rate of roughly one per year. We've been missing almost all of them. This validates the precursor theory completely. 3I Atlas isn't the first, it's the loudest. The Cassandra network, if it exists, was likely built because this faint, strange signal was detected increasing in strength and frequency. The culmination of all this is a revised understanding of our own home. In late December, new modelling of data from the IBEX and Voyager missions revealed the heliopause, the boundary of our solar system, is not a fuzzy, gradual transition. It is, in certain regions, an astonishingly sharp and structured wall. Its geometry correlates with the galactic magnetic field and, strikingly, with the entry points of the anomalous objects flagged by the AI. It's as if our solar system is a defined cell, with walls that are more complex and coherent than we knew, and these objects are coming through specific, perhaps weaker, points in that wall. So, what is the real story of 3I Atlas? The evidence points to a convergence. A pattern of anomalous interstellar objects has been increasing. A secret surveillance network conceived decades ago was built to study this pattern. It detected the biggest signature yet and tracked it with breathtaking detail. The object itself exhibits a constellation of features: structured plasma, anomalous acceleration, potential EM emissions that collectively push the limits of natural explanation. Concurrent breakthroughs in quantum sensing, gravitational wave mapping, and plasma physics now provide both the tools to detect such phenomena and a cosmic backdrop that suggests our galaxy is structured in ways that could support regular, non-random traffic. The beacon hypothesis remains the most profound interpretation. 3I Atlas, in this view, is a marker. Its arrival, its timing at the peak of our technological awakening to these new senses, and its delivery of a data package via leak that forces us to look, all feel orchestrated at a cosmic scale. Perhaps the beacon's message is simply, you are not alone, and you are now looking. Perhaps its purpose is to trigger the very technological and conceptual revolution we are now undergoing. We stand at a threshold. The leaked files may be authenticated or debunked. 3I Atlas will soon vanish from our view. But the questions it raised cannot be unasked. The capabilities it implied cannot be unimagined. The scientific breakthroughs it coincidentally preceded have permanently altered our perceptual horizon. Whether 3I Atlas was a natural wonder or an artificial marker is almost secondary. Its true legacy is that it has shattered our cosmic myopia. It has forced us to admit that the darkness between stars is not empty. It is a deep, structured, and potentially active ocean, and we have just begun to dip our toes in the water, finally learning how to see the currents, the waves, and the distant, mysterious lights that may be moving within it. The story isn't over. It has just begun, and now we're watching.